All right, here we go. Video on solving systems by substitution. So we've seen the introduction, we've seen graphing. And at the end of the graphing video, I mentioned that there are a number of systems. If you're thinking about the infinite number of possible systems, the majority of those are probably not integer answers, meaning you have decimals, you have fractions. And what you need to do is you need to have a technique that can find those easily and accurately. So graphing is not going to do it for you, right? Because then you have to guess. We don't want to guess. That's not accurate. So the first method we have to deal with that is called substitution. Substitution is exactly what you think of when you think of the word substitution. It's basically taking one equation and putting it inside the other. So the first step, you need to have one equation solved for one of the variables, x equals or y equals. Now, sometimes they'll do that for you, sometimes you'll need to do it. After that, take that equation, so if it's like y equals 3x, into the second equation, wherever you see y, put 3x, because that's what it's equal to. Solve that equation. And then you have to plug that value back in to find the other variable. What you are doing here, looking at this system, what you are doing here is if you have something like this, you have two equations, both with two variables. You are putting them together to come up with one equation with one variable, since that's what you know how to solve. Now, this is a particular type of equation system that messes with people. They get intimidated by it because they're not sure what to do aside from graphing. It's no different than what I just read on the previous slide. We have the first equation solved for a variable. We also have the second one solved for the same variable, but I don't care about that. All I care about is that y equals negative 3x minus 22. And the other equation has a y in it. So that means wherever I see y in the second equation, I am going to put what y is equal to, negative 3x minus 22. Just that. I don't need another y. I don't need another equal sign. One equal sign in a problem is enough. Negative 3x minus 22 is equal to 4x plus 13. Now, see what I did there? We went from two equations, each with two variables, to one equation with one variable on both sides. And now we just do what we learned way back at the beginning of Algebra 1 and solve that equation. We're going to add 3x to each side to keep x positive. We're going to subtract 13 from each side to get the x somewhat by itself. So I get negative 35 equals 7x. Divide both sides by 7. Negative 5 is x. But I'm not done. I wasn't asked to solve for y. I was asked to solve the system. That means finding an answer, an ordered pair xy, that works in both of those equations. I have just found the x, negative 5. I need to find the y. Now, you can choose whichever equation you like. I'm going to take the first one just because it's first. And like I said, whatever you want. If you wanted 4x plus 13, you can use that as well. Put the negative 5 in and solve. Negative 3 times negative 5 is positive 15 minus 22 is negative 7, and that's y. And then you can check your answer the same way you check anything else by plugging it back in. So in this case, I will use that second equation just because that way I can say I've checked in both equations, right? We know that it works in the first one because that's how we found the y equals negative 7. So let's simplify. Negative 7 equals 4 times negative 5 is negative 20 plus 13. Negative 7 equals negative 7. That is valid, so that is the answer. Negative 5, negative 7. Right? Now, number 4 is a little bit easier. Why is it easier? Well, as you can see, I've given you the y. So the same as in the graphing. if we're looking for an ordered pair x, y, don't make this harder on yourself. If I've told you what y is, just put it right in there. Y equals 5. That means in the second equation, wherever I see y, a 5 can go. So 5 is equal to 5x minus 20. And then I'm going to solve this. And with this one is a little bit easier than the last one because the variable only shows up once. It's just a two-step equation. So I get 5 equals x. And the solution is 5, 5. And if you check that, you would find that it works. Right? This one's a little different. This one's different because they're not both solved for a variable. Only one is. But the principle that we just talked about still applies. We know that y is equal to negative 5x minus 10. That means in the second equation, wherever I see y, I can replace it with negative 5x minus 10. So I can say negative 2x plus positive 2, plug in negative 5x, substitute negative 5x minus 10 for y, equals 16. And there's the substitution. That's why it's called substitution. You are substituting, you are replacing y with something that it is equal to in that other equation. Okay, solve. Negative 2x, distribute, minus 10x minus 20 equals 16. Combine like terms. Negative 12x minus 20 equals 16. Add 20 to each side. Negative 12x equals 36. Divide by negative 12 on each side. X equals negative 3. Don't stop there. I have to find y. In this case, I would say that it is much easier to go ahead and find y using the first equation because it's already set up to tell you that. Y is equal to whatever happens when negative 5 times x minus 10 happens. And now I know that x is negative 3. And I would get positive 15 minus 10, which is 5. So my answer is negative 3, 5. Now, is it acceptable to write x equals negative 3 and y is 5? Yes, that is acceptable. However, I really want to encourage you to use the ordered pairs, since that is the proper way to write that answer. We are still dealing with lines in the coordinate plane, even though we're not graphing them. Okay? All right. I think it's time for you to do some practice. So hit pause, try this one out, find both x and y, and then hit play when you're ready to go over the answer. And the answer here is 1, 1. So I substituted 2x minus 1 in for y into the second equation, did the distributive property and combined like terms. So I got 6x minus 2 equals 4. Add 2 to each side, so I get 6x equals 6. Divide both sides by 6, and x is 1. Plug that 1 back in, y equals 2 times 1 minus 1, which is 1. 1, 1. All right, our last type of problem is a little bit more complicated. As you can see here, neither equation has been solved for x or y. Now, that is not necessarily a problem. Now, I will be honest with you, the last video that we will be doing on systems of linear equations with elimination gives you a method to solve things that look like this. But some people prefer to use substitution all the time. So I'm going to show you how to solve using substitution when one of the equations, I should say neither of the equations, is solved for a variable. You have to solve for a variable. So what you want to look for is something like this. I see 1x here. That is very easy to make into an x equals equation. Notice how both x and y in the first equation have a coefficient. That's not to say you can't solve that one for x or y, just that it will be more work than you might want to do. Okay, So in this one, we're going to just simply subtract 3y from each side. So I get x, actually I'm going to go next to it. X equals negative 3y minus 16, or you could say negative 16 minus 3y. It means the same thing. Now I can take this and put it into the first equation for x. So I would say 8, and I'll leave some space to plug in, plus 2y equals 4, and in for x goes negative 3y minus 16. Okay, and then I'm going to distribute. 8 times negative 3 is negative 24y. 8 times 16, well, that's 80 plus 48, so that's 128, plus 2y equals 4. Okay, and then from there, I'm going to combine like terms. Negative 24 and positive 2 is negative 22y minus 128 equals 4. I'm going to add 128 to each side. So I get negative 22y equals 132. And I'm going to divide both sides by negative 22. And I will get y equals, and we're going to consult the calculator here. So we've got 132 divided by 22. I know the 22 is negative 6, so that would be negative 6. Okay? Now I have to solve for the other variable. I have to solve for x. The first thing I want to say, just as way of a reminder, when you write your final answer, please remember that that negative 6, even though you found it first as the y coordinate, sometimes students will always put the first thing they find in as x, just because they get used to that. So you got to pay attention. You wrote y equals negative 6. Negative 6 is the y coordinate. You can choose what to do. I'm going to actually use the original first equation. And the reason I do that is just because if I made a mistake, it's better to use what I was given than what I found. So I get x minus 18 equals negative 16, and I'm going to add 18 to each side. X equals positive 2. So 2 negative 6 is the final answer. Okay? All right, try this one. Pick the one that you think should be solved and what variable it should be solved for, and then use your substitution. And the answer is 2, negative 13. So I noticed that in the first equation, y was already just 1y. So it was easy to get that one to be y equals by subtracting 4x from each side, so that's what I did. Then I plugged in negative 4x minus 5 for y in the second equation, and I got negative 3 minus 6 times negative 4x minus 5 equals negative 12. Used the distributive property, combined like terms. 21x plus 30 equals negative 12, and solved x equals 2. And actually that should be negative 2, now that I look at it. So that'll change our answer for y. So this would be a negative 8. So I would be adding 8 on each side. So this would actually be positive 3. So the answer is 2, 3. So with this one, negative 2, 3. And then with this one, again, I could have solved for x in the first equation. That wouldn't have been pleasant, but I could have done it. I could have solved for x or y in the second equation. Might not have been pleasant, but I could have done it. But solving for y in the first equation was the right decision, or I should say the easiest decision, because it was already just 1y. All right, thanks for watching. Tune into the last video on elimination.